Hey everybody, it's Mr. Barbier back with another video. Today's topic is Introduction to Functions. Okay, so this video is part one of a two-part video covering this topic, Introduction to Functions. So let's get right into it. It says, Introduction to Functions. Let's learn about functions. We'll start by learning some function vocabulary. So let's remember that vocabulary is very important in math. It's just as important in math as it is in any other subject, okay? So let's get right into our function vocabulary. And our very first vocabulary word is relation. A relation is a set of ordered pairs, also known as coordinates. The first coordinate in each ordered pair is the x value, and the second coordinate is the y value, okay? So let's look at this example. The set, and you see these little, what my students like to call swigglies, those are called braces. So this little wavy type of parentheses or brackets are known as braces. They're in the parentheses family. Usually when you are listing a set in math, braces are used, okay, to keep the set inside. So whenever you see braces, usually in math, that refers to a set of something. It could be a set of anything, really. But in this case, we're talking about a set of coordinates, also known as ordered pairs. All right. Again, the first value, or also known as the first coordinate, is called the x value or x coordinate. The second value within the parentheses of each ordered pair is the y value. So again, the first number here, first coordinate, is the x. The second number is the y for this these coordinates here, this first pair. And then same thing with this pair. We have our x and then we have our y. And then we have our x and our y, our x and our y, and our x and our y. So again, the braces indicates that we have a set, and each of these ordered pairs, okay, is within the set, and we call that a relation. Okay, again, a relation is a set of ordered pairs. Okay, first value is our x value or x coordinate. Second value is our y value or y coordinate. Okay, let's go. Number two, domain. The domain of a relation is the set of all first coordinates, okay, as we know, also known as x values of the ordered pairs. All right, so the domain, okay, get used to that word, domain. When we hear the word domain, we know we're talking about all of the x coordinates only, okay? Only the x coordinates. Each element of the domain is also known as the input, okay? So when you're talking about the domain, you're talking about the input. Let's look at this example. In the relation, right? This is the same relation as up here, no difference. But now notice what I did. All of the first values, the first coordinates, I marked in red, okay? Why? To make them stand out so that you know that these numbers alone represent the domain, okay? That's the key. First number, which is the x value, as we said earlier, those are called the domain. And as it says here, in the relation, right, this relation here, the domain is, and look what I did, right? I took only the first value of each ordered pair and I put them in its own set of braces, okay? Because I told you, braces are used to list a set. So now we're not listing a set of ordered pairs. Now we're listing the domain, the elements of the domain. So each of these numbers, right? Notice each of these numbers are the same numbers that were here, but the ones that came first in each pair of, in each ordered pair, right? In each set of parentheses. So look at this. See, look, -2, -1, 0, 1, 2. And look here. Same thing. -2, -1, 0, 1, and 2. That is known as the domain. All of the first coordinates or x values of the ordered pairs. Very simple, right, guys? Very simple. Okay, let's continue. The range. So, folks, if the domain of a relation is the set of all first coordinates, also known as the x values, then the range of a relation is the set of all second coordinates, also known as the y values of the ordered pairs. Okay? Each element of the range is also known as the output. Okay? So one thing you know about math is all about patterns, right? So if the domain is called the input, then the range is called the output. All right? And let's take a look at the same exact relation, right? The same set of ordered pairs that we've been dealing with all along. Now what I'm doing is notice the second number, not the first anymore, the second number in each ordered pair, right? Which is enclosed in the parentheses. The number that comes second is marked in green, and that is my range. Okay, so let's look at them. We have 3, 0, -1, 0, and 3. Let me zoom in a little bit, okay? So, again, 3, 0, -1, 0, 3. Now, when I take these numbers, right, that represents the range, and put them in a set, in its own set, look here, right? So, in the relation, here it is, the range is 3, 0, -1. Now, some of you are saying, wait a minute, Mr. Barbie, hold on. How come up here you had 5 numbers, but down here you only have 3? Because some of the numbers, did you notice, repeated themselves. I have 3 here, and I have 3 here, okay? Both are y coordinates, second coordinates, okay, y values. I have a 0 here, and I have another 0 right here. Again, they are y values, second coordinates. Okay, they are y coordinates. They come second, not first, within the ordered pair. So what happens in math is this, right? When we list the elements of the domain or the range, and we have numbers that repeat, we only write them one time. Let's take a look at that note. Note, if a number repeats, notice that there are 2 zeros and 2 3s. If a number repeats, okay, so if a number repeats, right, and I said again, notice that there are 2 zeros and 2 3s in the range. We only write it once when listing elements of a set. Okay, very important to know that. When you are listing the elements of a set, you never write any element or any number more than one time. You only write that number one time if it repeats itself. Now, I know what some of you are thinking, so let me answer the question right now. Mr. Barbier, what if all of these second coordinates were the same number? What if it was, for example, 3, 3, 3, 3, 3, nothing but 3s as my second coordinate? What do I put in the parentheses? You would just put open braces, 3, close the braces. That's it. Okay, guys, you hear that? Very simple. Now you're saying, wait a minute, Mr. Barbie, you mean a set can be only one number? Yes, absolutely. Okay, a set can be one number alone. So let me say that again in case you guys didn't catch that. If all of these second values, the second coordinates, the y values, if all of them said 3, 3, 3, 3, 3, 3, the range is open braces 3, close the braces, finito, that's it, done. Okay, very simple, very simple, very simple. So a set can be just one number, okay, or one value, okay, so that's one element, another word for that. Okay, let's continue. We have one more vocabulary word, and the word is function. Okay, so a function is a relation in which no two ordered pairs have the same first coordinate. Let's look at that again. We've been talking about a relation this whole time, right? We have the relation written up here. We use the same relation here. We use the same relation here. And what we're saying is that a relation is a function if and only if it meets this criteria. No two ordered pairs have the same first coordinate. Okay, let's continue with that. A function rule to remember is this. For each input, x, there is only one output, y. All right? So we're going to get into that very, 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 very carefully and very specifically so that you understand what exactly is going on. So if a function, let's just answer this question really quick. If a function is a relation in which no two ordered pairs have the same first coordinate, basically, to keep it simple, we can't have the x repeat itself. That's what we mean. That's what we mean. So someone tell me right now, okay? Somebody tell me right now. Let's go back to our x values in this relation that we've been talking about this whole time. Let's look at this. Look, the domain is our x values, right? Our first coordinates. So look at this. -2, say it for me. -2, let me hear you. -1, good. What else? 0, 1, and 2. Question. Did we say the same number twice? In other words, let me say it another way. Did you see a number repeat itself in the domain? Okay, I'm hearing somebody say, Mr. Barbier, yes. Really? Okay, where? Where do you see the same number? I see there's a 2 right here, and there's a 2 right here. And there's also a 1 right here, and a 1 right there. That means it's not a function because it repeats. Wait a minute. Does everybody agree with that? Okay, wait, I'm hearing somebody say, no, Mr. Barbier, because this is a -2, and that's a +2. And this is a -1, and that's a +1. They're not the same number. Oh, you know what? You're right. So if it's not the same number, can you tell me, does this relation represent a function then? Oh, okay, thank you. Yes, you're saying yes, and you are correct. So ladies and gentlemen, this relation, we've been talking about this entire time, this relation is a function because none of the first coordinates are exactly the same. They're all different. Okay, now some of you are going to ask, wait, but Mr. Barbier, what about the second coordinates? There's a 3 here and a 3 here. And there's a 0 here and a 0 here. They repeat. Guess what? That doesn't matter. Okay? So to be very, very clear, the first coordinates cannot repeat for the relation to be considered a function. But the second coordinates can repeat. That doesn't matter. We're going to go into more detail with that later on. Don't worry if you're still a little confused. All right, let's continue. Part B, relations in the form of visual displays. So let's read this together. We know that relations can be represented as a set of ordered pairs, but there are 3 visual displays in which relations can be represented. 1 in a table, 2 in a diagram, and 3 in a graph. Okay? In the graph, a point is placed on the coordinate plane at the location given by each ordered pair, which is the graph right here. Okay, so but before we get to the graph, let's look at all three very carefully. So ladies and gentlemen, this is what I did. I took the same relation we've been talking about all along so far in this video, and I'm representing it in three different visual displays. So notice in the table display, let me zoom in. We have the left side of the table labeled domain. Again, we know the domain is all of my x values, okay, the first coordinates. And the second column is the range, okay, which we know is the set of all of my y values or second coordinates, all right? So folks, don't get confused. I want you to understand that the same way we have it written here, you see, -2, -1, 0, 1, and 2 are the numbers that come first in the ordered pair, right? The same numbers go down the line right here, okay? And the same numbers that came second are right here. Now, one thing I know you might be thinking, Mr. Barbie, you said you can't write the numbers twice, right? The 3 and the 0. Well, no, that's only if I'm listing the set of the range, meaning if I wanted to list the range as a set, then I don't write the number twice, okay? But if I'm basically displaying the relation in the form of a table, then yes, it is fine for me to have the numbers written more than once, all right? Just to make that clear. Now, this same range listed in the form of a table, okay, the same relation I meant to say, listed in the form of a table, here it is in another display as a diagram. Notice I still have this side labeled domain, but I have an oval now with the numbers here. And this time, look at this, the range, only the numbers that don't repeat. Okay, so you see the difference? In a table, I can show repeating numbers in the range or domain. But in a diagram, I do not show repeating numbers in the range or the domain. Okay, so the domain, I listed all of the numbers here because none of them repeat. But in the diagram, right, for the range, I only write the numbers that appear one at a time. I don't write the 0 twice. I don't write the 3 twice. But look carefully. Look at this. You see 2 arrows pointing to the 0? That tells you the 0 is being used twice. You see the 2 arrows pointing to the 3? That tells you the 3 is being used twice. Okay? So that's how you don't get confused. One more visual display, the graph. Now, again, all 3 displays represent the same relation. So notice, right, I have my coordinates, -2, 3, and I have a point on this graph, okay, which is known as a coordinate plane. Okay, another word for coordinate plane is Cartesian plane. And that point represents the location of these coordinates, okay? So the first number is the x, the second number is the y. So let me show you something very quickly. How do you plot a point on a graph? It's very easy, okay? It's very easy. All you do is, for example, if I tell you, plot the point -2, 3, you start right here. This is called the origin, right there. The origin is where the y-axis, that's why it's labeled y, and the x-axis, right? That's where they intersect. Where they intersect is called the origin, okay? Now, I start here. This is my starting point. I always start at the origin. And if I want to plot this point, -2, 3, I have to remember that -2 is the x value and 3 is the y value. And because x comes before y in the alphabet, I always go in the direction of the x value first. Okay, so let me explain what I mean. Start at the origin. Okay, I want to plot this point. So x comes first, which is -2. So that means I'm going to move 2 units. Now you might say, Mr. Barbier, do you move up, down, left, or right? Well, since the first number is my x value, I move along the x-axis, which means I'm going to move either to the right or to the left, right on the line. But now you're saying, well, which direction do you move, left or right? You go by the sign of the number. So since the 2 is negative, I move from the origin going to the left twice. Okay, so look, I start here and I go 1, 2. Notice how when I move, I jump from one intersection or one, corner, if you want to call it that, to another corner. And then again, from this corner to that corner. Make sure you don't, notice I'm not counting boxes, I'm not counting spaces. No, I'm jumping from one intersection of these, what we call in math, crosshairs, right? This is a crosshair going down, this is a crosshair going across, and where they meet is what we call in math a point. So I'm starting from the origin, and I move to the left. Why? Because it's negative twice. So I'm going to go here 1, 2, and I stop. Now notice I'm not going to make a dot yet. Do not make a point yet. I just stop there. And now, as I stay there, I look at the coordinates again and I say, okay, my first coordinate is -2, the x, and now I'm going to move 3 units, either up or down, because 3 is the y value. Okay, so the x value tells me to go horizontally, left or right. The y value tells me to go vertically, up or down. So since the 2 was negative, I went left instead of right. The 3, however, is positive. So because the 3 is positive, I'm going to go up 3. Count with me. 1, 2, 3, and then I make the point. Okay, folks, that's how it works. So again, let me do that in a little faster way so that you can all follow me. I want to plot this point, -2, 3. Start at the origin. The 2 is negative, which is my x value, so I move to the left. 1, 2. The 3 is positive, so I'm going to go up now. 1, 2, 3, and I make a point. It's that simple. Okay, that's how you plot points, okay, on a coordinate plane. Okay, let's look at another set of coordinates. Okay, let's say I want to plot, let's say the coordinates 2, 3, right here, right? 2 is my x, 3 is my y. Again, start at the origin. Now, the 2 is positive, which means I go to the right now on the x-axis. 1, 2, stop there. The 3 is also positive, so from here, I'm going to move up 3, 1, 2, 3. I plot my point. Okay, so we're going to be practicing plotting points later on, but I just want to give you a little introduction to plotting points right now, just to kind of, give you a little bit of insight on coordinate planes and what we call in math coordinate plane geometry. Okay, that's what this is, basically, coordinate plane geometry. All right, and finally on this page, I want to say this last part. All 3 displays above, meaning this display, this one, and this one, all 3 displays above represent the same relation, which is -2, 3, -1, 0, 0, -1, 1, 0, and 2, negative. I'm sorry, +2, +3. Okay, all 3. All three displays same relation. So to be clear, a relation can be represented in 4 different ways then. Okay, it can be represented like this, as so, right? In the form of coordinates, okay, which I put here in this yellow box. These are called coordinates. This is one way to represent a relation. Another way is in the form of a table, another way is in the form of a diagram, and another way is in the form of a graph. Okay, these three are visual representations, and this is just, in the form of coordinates, okay, which is not really visual. But all four, right, 1, 2, 3, and 4 are the same exact thing. All right, hope you got that. Let's move along. Let's look at the back. Now, how to determine whether a relation is a function. Well, we already talked about this, so this should be very easy for us to catch on to, right? I already gave you some information earlier. Let's see who remembers. So let's read. All functions are relations, but not all relations are functions. How can we determine whether a relation is a function? Let's look at all four ways to represent a relation and find out how to answer this simple question. Is it a function? Okay, let's do it. So the first way we know how to represent a relation is as a set of ordered pairs. Okay? Relation as a set of ordered pairs, is it a function? When a relation is given in the form of ordered pairs, how do we know if it is a function? Follow the steps below. Step 1, label the first coordinate with an X and the second with a Y by writing it on top of each number of the ordered pair. Continue to label all of the ordered pairs the same way. Number 2, look to see if any of the X values are repeated. Okay, remember we talked about that before, right? Do you see the X's repeating or not? Okay, if you see any, box them. Okay, if you see any repeating numbers, I want you to draw a box around them. Number 3, if there are any repeating X values, it is not a function. Okay, it's that simple. All right, but if none of the X values repeat, it is a function, and that's it. It's that simple, guys. It's that simple. All right, so here's what we're going to do. Usually, I create different problems in my notebook for you to do, but this time, because it's a very easy topic, what I'm going to do with you is this. We're going to do the example together, the two examples, and then you are going to solve the classwork practice right here. Maybe if I'm nice, we'll do one classwork practice together. Maybe one of them, and then the other two you'll do by yourself. Okay? All right. Example. Determine whether each relation given below is a function. Okay, example A. Is the relation -2, 3, -7, 0, 8, -6, 4, 4, 2, 3 a function? Well, let's follow my steps. Here it is. Step 1, I wrote it right here. Label the first coordinate X and the second Y. So look what I did. You do the same thing, okay? I took the relation, and on top of each number, I labeled my first number X, the second number Y. First number X, second number Y, etc., etc., and I kept it going. You do the same thing, okay, when you do these classwork practice problems. So, after you label the first coordinate X and the second coordinate Y, now I want you to look and notice. Look, let's notice. Notice if we see any X's that repeat. So say these numbers out loud for me, okay? Say them out loud. I want to hear you because I can hear you through the video, believe it or not. Say that number. What is that number? Okay, -2. What is this? -7, 8, 4, 2. Here's my question. Do you see any x's that repeat? Any x coordinates, any first coordinates, did any of them repeat? Okay, someone just said, Mr. Barbier, yes, I think so, but I'm not sure. So, well, what do you mean? Because I see a 2 here and I see a 2 here. That's the same number. Does everybody agree with that? Wait a minute, I'm hearing someone else say, wait a minute, Mr. Barbier, I don't think any of the x's repeat. How come? Why? Because this is a -2 and this is a +2. They're not the same number. One is negative, one is positive. You're right. They're not the same number. Okay, do you see any other repeating x's? No, because this is -7, that's 8, that's 4. So since none of the x's repeat, let's take a look at this note that I wrote. Notice that none of the x coordinates repeat. This relation is a function. Some of you are thinking, Mr. Barbier, you mean it's that easy? Yes, it's that easy. It's that easy, guys. It's that easy. Let's look at another example, okay? Because this is how dedicated I am to your success. Let's look at another example. Determine whether the relation, okay, here's the relation listed here, is a function. Determine whether this relation is a function. Okay, guess what? You look at it, and as I say all the time, you do it. Pause the video, you do it. Okay, time's up. You tell me, what do you see? Okay, someone says, Mr. Barbier, wait, I'm hearing someone say, Mr. Barbier, I see here 4, -3, 8, 4, and 9. And the 4s repeat because it's the same number and it's the same sign also. They're both a +4. Okay, so what does that mean? It means that what? Okay, you're saying it's not a function because we have 2 coordinates with the same x value? You are correct. Yes, you are correct. Very good job. Ladies and gentlemen, first we label, right? We label the first coordinate x, the second coordinate y. We did that. And now notice there are 2 ordered pairs with the same first coordinate of 4. This relation is not a function. It is that easy. It is that easy, that easy, that easy. So folks, you know what? I know you got this, okay? I don't think there's any reason for me to do any of these with you. I think you got it. I know you got it, as a matter of fact, okay? Let me take that back. I don't think you got it. I know you got it. So what you're going to do is you're going to do these 3 classwork practice problems, and please do it as I taught you, okay? I want you to write x, y, x, y, x, y, x, y. If you see any repeating x's, box them, okay, like we did here. And if you don't see any repeating x's, then you don't have to box anything. And one more thing, remember, don't worry about the y's. We only care about the number that appears first in the set of coordinates. We don't care about the second number, the y. The y does not help us to determine whether the relation is a function. Only the x does, okay? The domain, right, is what we care about, not the range. So you are going to do these 3 by yourself, okay? And as it says here, determine whether the relation is a function. You're going to circle yes if it's a function, or circle no if it's not a function, and then write on the line why, okay? Explain your reasoning, okay? Why is that important? Because I want to make sure that you didn't guess. You know what you're doing. You're not guessing, okay? In math, we want to know. We don't want to guess, all right? Very, 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 very good. So, ladies and gentlemen, guess what you are going to do right now? This is your homework. You are responsible for doing parts A, B, and C, which is on the back, okay? Part A is your vocabulary review. I'm giving you 8 vocabulary words. You must put the vocabulary word in the blank so that this sentence is an accurate statement, okay? So 8 vocabulary words, plug it into the blank. All right. If you have this printout, great. If you don't, simply write the number and write the vocabulary word that goes with that sentence. Okay. Part B, visual displays. I'm giving you a relation, okay, in the form of coordinates. You have to decide, as it says here, you have to decide which of these three visual displays is not an accurate visual description of this relation. Okay, which one of these is not? As it says here, which of the following displays is not a visual description of the relation given below? And so circle either A, B, or C, whichever one of these three displays does not accurately represent this relation, and then explain your reasoning on the line below. And then part C, which is on the back, I'm giving you a relation, and it says here, domain versus range. Answer questions number 10, 11, and 12 based on the relation given. And these are multiple choice questions, okay? Question 10, 11, 12, all deal with this relation in particular, right? And that's it. Now, the rest of the homework, I'll show you in the next video, because the next video breaks down the second half of Introduction to Functions. So ladies and gentlemen, go for it. Remember, okay, you are all very smart. I believe in every single one of you. Put the work in, study, and continue to be great, because you are. All right, I'll see you in the next video. Take care.